Machine learning with text using spaCy. Integrating spaCy in machine learning model is pretty easy and straightforward. Let us build a custom text classifier using sklearn. We will create a sklearn pipeline with the following components: cleaner, tokenizer, vectorizer, and classifier. We had previously implemented the text classification using various algorithms in the NLTK toolkit, but here we will be using the spaCy library where we see that it's simpler to use spaCy for text classification. For tokenizer and vectorizer, we will build our own custom modules using spaCy. We will import the word extraction feature from the sklearn package, and we will use English stopwords as the list of stopwords. We'll import count vectorizer, accuracy score, transformer mixin, and pipeline and linear SEC from the sklearn package. We will import the string and store all the punctuations in the string in the variable punctuations. And after importing the English library from the spaCy package, we will pass the input in English. We will use a custom transformer using spaCy, create an custom transformer where we have a class called predictors, where the transformer mixin is given as the input, and it has three functions. The first function, called the transform, will clean the text for every word occurring in that text, and we will fit that text within our required range and then get the parameters of the text. The basic utility function is used to clean the text and strip the text of its superseding and preceding spaces and convert it to lowercase. Let us now create a custom tokenizer function using spaCy parser and some basic cleaning. One thing to note here is that the text features can be replaced with word vectors, especially beneficial in deep learning models. We create a spaCy tokenizer that parses a sentence and generates tokens. These can also be replaced by word vectors. We create a function called spaCy tokenizer and give the input as sentence, which is then passed, and its words are lemmatized, and the lemma of the words are converted into lowercase and stripped of its preceding and superseding spaces. And we make sure that the tokens are not pronouns. If they are pronouns, we discard them. And if the words are not a part of the stopword library or the list of stopwords, we return the tokens. If they are present in the list of stopwords, we discard the tokens. We then create a vectorizer object to generate features which are vectors, which we will use to customize the species tokenizer. We use the count vectorizer function for the species tokenizer to create vectorizers, giving the species tokenizer n-gram range and classifier as the inputs. The classifier is linear SVC. SVC stands for support vector classifier, so it is linear support vector classifier. We are now ready to create the pipeline, load the data, and run the classifier model. We create the pipeline to clean, tokenize, vectorize, and classify the data. We create a pipeline for the cleaner, predictors, vectorizer, classifier, and so on. We load the sample data into the train set where we have the sentences I love the sandwich. This is an amazing place. I feel very good about these beers. This is my best work. What an awesome view. I do not like this restaurant. I'm tired of this stuff. I can't deal with this. He is my sworn enemy and my boss is horrible. Notice how there's indication that if a sentence is positive sentence or a negative sentence, this is the trained data set where it's indicated whether the sentence is positive or negative. Then we test unseen data into by giving it as the input to the model, which will indicate if the sentence is positive or negative. We have the sentences the beer was good, which is positive sentence which is marked correctly. Then we have I do not enjoy my job, which is categorized as negative. We then have I ain't feeling dandy today, which is termed as negative. Dandy is a synonym for the word excellent. So if someone is not feeling excellent today, it would be termed as negative, which is correct. We then have I feel amazing, which is a positive sentence. Gary is a good friend of mine is also a positive sentence. I can't believe I'm doing this is termed as a negative sentence, but this sentence can be contextual where it might mean positive in certain scenarios, such as I can't believe I'm learning natural language processing and it is so interesting, can be taken in the positive sense and not necessarily the negative sense. We then create a model and measure the accuracy. We fit the pipe model for the training set and use the prediction of the data, giving the test set as the input and print the accuracy score. Since most of our sentences, that is, or rather all of our sentences were marked correctly, we have an accuracy of 1 or 100%. We can now compare the Spacey library with the other libraries we had come across before. Spacey is a very powerful and industrial strength package for almost all natural language processing tasks. If you're wondering why, let us compare Spacey with other famous tools to implement NLP in Python. Those are Core NLP and NLTK. When we compare the feature availability, all the features we compare with the three libraries we have. The ease of installation is present in all the three packages. The Python API is present in SPACY and NLTK, but not present in Core NLP. Hence, we have not discussed the Core NLP package in our course. We have only discussed SPACY and NLTK. Multi-language support is present in NLTK and Core NLP, but is absent in SPACY. Tokenization is present in all the three. Parts of speech tagging is present in all the three. Sentence segmentation is present in all the three. Dependency parsing is present in SPACY and Core NLP. Entity recognition is present in all the three. Integrated word vectors is present only in the SPACY library. Sentiment analysis can be performed using all the three libraries. Core reference resolution is present only in the Core NLP.